Warm up. Find AB and BA if possible. We have, let's try AB. We have 3 rows by 1 column, and we're trying to multiply that by 2 rows by 3 columns. The inside dimensions do not match. We cannot multiply A times B. But what about B times A? What if we took a 2 by 3, this one, that's the B, times the A, 3 by 1. Now the inside dimensions are the same, and the result will be a 2 by 1. So we have 2 rows by 1 column as a result. So 2 rows, 1 column. We have 3 times 1 is 3, minus 3, that's 0, and plus 8, actually plus negative 8. So we have negative 8, and then we go across and down. We have 7, minus 6, and then plus 0. So that's going to be a 1. Let's take A times B. We have 2 times 4, that's 8, minus 7, that's 1. Then we have 2 times negative 7, that's negative 14. And 7 times 3 is 21. And that is not going to be 0. These are not inverses. Which of the following represents the determinant of 3, 2, negative 1, 5? So we're supposed to find the determinant. And to find the determinant, we cross multiply. We have 15 minus negative 2, which is 17. So letter D. Solving linear systems using inverses. Invertible square linear systems. Let A be the coefficient matrix of system of n linear equations and n variables given by AX equals B, where X is the matrix of variables and B is the matrix of constants. If A is invertible, then the system of equations has a unique solution given by X equals inverse times B. Use an inverse matrix to solve the system of equations if possible. We have 2, negative 1, 2, 3 times x, y is equal to 1, 13. Now we need to solve for x and y, and if we call this matrix A and we call this matrix B, then if we take A inverse times A and then A inverse times B, these two will cancel out, and our solution will be A inverse times B. Let's find the inverse of A. We have 1 over 6 minus negative 2, which is 1/8, and then we swap the 2 and the 3, 3 and 2, and then we do the opposite of the other ones. We have 1 and negative 2. And then we can multiply that times 1, 13, and we can get our answers to x and y. Let's leave 1/8 till the last, and we have a 2 by 2 times a 2 by 1, so the result will be a 2 by 1. We have 3 plus 13, that's 16, and negative 2 plus 26 is negative 24. And then 1/8 of that would be 2 and negative 3. So the solution is 2, negative 3. Use an inverse matrix to solve the system of equations if possible. Let's set up the equation. We have 2 Let's set up the equation. We have 2, 1, 0, and we have 1, negative 3, 2, and 5. We start with 0. 0, 5, negative 3. And we're multiplying times x, y, and z. And that's equal to, we have 9, 12, and negative 11. In our calculators, let's clear this. We can go to matrix, and we have edit, and we'll make this a 3 by 3. And we have 2, 1, 0, 1, negative 3, 2. And we have 0, 5, negative 3. And then let's quit out, go back into matrix. Let's go to B, Let's go to B. We can edit. We can make this a 3 by 1. We have 9, 12, negative 11. We can quit, and we want to, if I call this one A and this one B, what I really want is A inverse times B. We can go to matrix A, and the inverse button is actually the same button for matrix, and then we have times matrix B, and we have 5, negative 1, 2. Use an inverse matrix to solve the system of equations if possible. We have 2, negative 3, negative 1, negative 1 times x, y is equal to negative 7, 1. If we call this one A and call this one B, we need A inverse times B in order to solve this. We need A inverse, which is 1 over, we have negative 2 minus 3, which is negative 1/5, and then times negative 1, 2, 1, 3. Then multiply that times negative 7, 1. That's equal to negative 1/5 times, we have 7 plus 3 is 10, then we have negative 7 plus 2 is negative 5. That's equal to negative 2, 1. So we have negative 2, 1 as the solution. Marquise has 22 coins that are all nickels, dimes, and quarters. The value of the coins is $2.75. He has 3 fewer dimes than twice the number of quarters. How many of each type of coin does Marquise have? So he has 22 coins that are nickels, dimes, and quarters. So nickels plus dimes plus quarters is equal to 22 total. The value of the coins is $2.75. So 0.5, actually we can go 0.05 nickels plus 0.1 dimes plus 0.25 quarters is equal to 275. He has 3 fewer dimes than twice the number of quarters. So if dimes equals the number of twice the number of quarters, he has 3 fewer dimes. So if we add 3 to the dimes, that will actually equal 2 times the quarters. So how much of each type of coin does Marquise have? Set up matrix equation, then use inverse matrix to solve. We have, what do we have? Dimes minus 2 quarters is equal to negative 3. We can go into matrix and we can edit B, and this is a 3 by 1, and it's 22, 2.75, and negative 3. Quit out of there, and we already have the A inverse times B, so we have 7, 9, and 6. 7 nickels, 9 dimes, and we have 6 quarters. Find the solution to the matrix. If we call this matrix A and this matrix B, then we can take A inverse times B and find the solution. A inverse is, let's see, we have 1 over 2 minus 3, so that's negative 1 times, we have negative 1, negative 2, negative 3, negative 1. So we can write that as 1, 1, 3, 2, and then times 4, 0, negative 2, 3, which is equal to, we have 4 minus 2 is 2, we have 0 plus 3 is 3, we have 12 minus 4 is 8, and we have 0 plus 6 is 6. We have the point 2, 3 for x1, y1, and we have 8, 6 for x2, y2. Solve the systems of equations using reduced row echelon form. This problem will not fit on this page. Write this one down in your notebook. So we're going to do reduced row echelon form, which means we have 1, 1, negative 2, negative 4. We have 1, negative 2, 1, 5, negative 1, 1, 3, 4. And we want the main diagonal to be 1s and everybody else needs to be 0s. We can do row 1 minus row 2, replace row 2. 1, 1, negative 2, negative 4. We have 0, 3. Negative 2 minus 1 is negative 3, and negative 4 minus 5 is negative 9. We can also do row 1 plus row 3 and replace row 3. We have 0, 2, 1, and 0. The next 0 we need to get is the 2. We got to make the 2 0. We can do 2 times row 2 minus 3 times row 3 and replace row 3. We have 0, 6, negative 18, and here we have 6, 3, 0. 1, 1, negative 2, negative 4. We have 0, 3, negative 9, and 0, 0. We're subtracting. Negative 6 minus 3 is negative 9. Negative 18 minus 0 is negative 18. Well, now we can take negative 1/9 times row 3, and we can replace row 3. 1, 1, negative 2, negative 4. We got 0, 3, negative 3. Actually, we can make things a little easier on ourselves, and not only can we do this process, but we can also take 1/3 times row 2 and replace row 2. We have 0, 1, negative 3, and then we have 0, 0, 1, 2. Our next 0 we want is right here. We want to get this to be 0. We can take, let's see, row 2 plus row 3 and replace row 2. 1, 1, negative 2, negative 4. We have 0, 0, 1, 2. And then we have 0. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus negative 1 is 0. And 2 plus negative 3 is negative 1. The next 0 we want is right here. We want to get this corner. Let's see, what can we do? We can take 2 times row 3, add to row 1, and replace row 1. All right, so we're replacing row 1. 0, 1, 0, negative 1, 0, 0, 1, 2. And then we're taking 2 times row 3. That's 2 and 4. We have 0 and 1 is 1. 0 and 1 is 1. 2 plus negative 2 is 0. And 4 plus negative 4 happens to be 0. Well, now our final 0 we want right here. We want that to be 0. Now how can we do that? Well, we can take row 2 minus row 1 and replace row 1. So 2 minus 1. 0 minus 1 is negative 1. So we have negative 1. 1 minus 1 is 0. 0 minus 0 is 0. And negative 1 minus 0 is negative 1. We have 0, 1, 0, negative 1, 0, 0, 1, 2. We probably should have minus the other way around, but now we can take negative 1 times row 1 and replace row 1. That would have saved us this step right here. We have 1, 0, 0, 1, 0, 1, 0, negative 1, and then 0, 0, 1, 2. So now our solution is 1, negative 1, 2.